Hello everyone. Today I am going to discuss about the class 10. The chapter name of the chapter is chemical reaction and equation. So I am going to discuss this chapter through English and Bengali. So don't worry about the language barrier. I will discuss in both the language. So don't worry. Okay. Now let's start the chapter. Okay. Here I am thoroughly discussing about all the details of the chapter. Basically, here I am discussing all the details of the chapter and the what meaning of this chapter. Okay, let's start. So, the name of the chapter is chemical reaction and equation. Uh, okay, 1 minute. Please wait 1 minute. Okay, I'm checking the connection of the PC. It's okay. Okay, is the sound is properly capturing? Okay, thank you. So, chemical reaction and equation. Consider the following situation of daily life. Think that what happens when milk is left at room temperature during summers. Okay, we can study, you can study with me thoroughly. Okay, it is not one shot video, it is a thoroughly study video, so you can study with me. Okay, milk is left at room temperature during summers. Here it is said that consider the following situations of daily life. Think what happens when milk is left at room temperature during summers and iron or tawa pan nail is left exposed to humid atmosphere. Grapes get fermented, food is cooked, food gets digested in our body, we respire. Okay, this is the condition. Now on the another para, in all the above situations the nature and the identity of the initial substances have somewhat changed. It have already learned about the physical and chemical changes of matter in our previous classes. Okay, physical and chemical changes. Whenever a chemical changes occurs, we can say that a chemical reaction has taken place. Okay, you may perhaps be wondering as to what is actually meant by a chemical reaction. Okay, how do we come to know that a chemical reaction has taken place? Let us perform some activities to find the answer of this question. Here basically said that telling here basically the book is telling that how do we come to know that a chemical reaction has taken place? How do we come to know? Okay. Now question activity. The question the activity needs the teacher assistance. Okay, it would be better in students. Okay, wear eye protection. It is the basic things we have needed. Clean a magnesium ribbon and don't and this is my first class which is totally in English language, so please cooperate with me. Okay, thank you all of you. Hold it with a pair of tongues, burn it using a spirit lamp or burner, collect the ash. Okay, this is these are the ingredients. What do we observe? Okay, this is the chemical reaction. Sorry, this is the diagram or picture of the reaction. Burning of magnesium ribbon. This is the magnesium ribbon in air and collection of magnesium oxide in watch glasses. This is the watch glasses. This is magnesium oxide, collection of magnesium oxide. This is the burner and tongue. Okay, I will go to the next page. You must have observed the magnesium ribbons burns with a dazzling white flame. This is important, white flame, magnesium ribbon, and changes into a white powder. It is important that it converts into a white flame. Magnesium here, magnesium ribbon converted into a white flame and changes into a white powder. This powder is the magnesium oxide. This is magnesium oxide. Okay, it is formed due to the reaction between the magnesium and oxygen. The magnesium and oxygen. Okay, magnesium and oxygen, it is formed due to the presence of magnesium and oxygen. Now activity 1.2 and 1.3. Now 1.2, take take lead nitrate solution in a test tube. Lead nitrate solution here, lead nitrate solution, uh, add potassium iodide to this. What do we observe? Potassium iodide. Okay, and activity 3, formation of hydrogen gas by the action of dilute sulfuric acid. No, this is not the diagram. Take a few zinc granules in a conical flux or a test tube, add dilute hydrochloric acid or sulfuric acid. This is the diagram, activity 1.3. This is the diagram. Okay, handle the acid with care. Do you observe anything happening around the zinc granules? Touch the conical flask or test tube. Is there any changes in temperature? Now, from the above three activities, we can say that any of the following observation helps us to determine whether a chemical reaction has taken place: change in state or change in color, evolution of gases, change in temperature. These are the main uh, determining factor. Okay, as we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical equations and their symbolic representation in this chapter. Okay, we'll study the various types of chemical reaction and their symbolic equation. This is the main purpose of this chapter. Okay, we'll read about the different types of chemical reaction, how many types of chemical reaction and their symbolic equation or representation, how to represent the equation. This is the main purpose of this chapter. Okay, now we'll go to the next para, chemical equation. Okay, chemical equations. Activity 1.1 can be described as when a magnesium ribbon is burnt in oxygen. Now magnesium ribbon is converted into magnesium oxide, which is white in color. This is the main important information from this, from the previous para. Okay, it gets converted to magnesium oxide. Okay, magnesium oxide. This description of a chemical reaction in a sentence from a quite long. It can be written in a shorter form. The simplest way to do this to write it in the form of a word equation. Okay, word equation is the simplest form to express the equation. The word equation for the above reaction, that means 1.1 activity, would be magnesium plus oxygen equals to magnesium oxide. This is the reactants. These are called the reactants and this is called the product. Okay, the substances that undergo chemical change in a reaction 1.1, magnesium and oxygen, are the reactants. The new substances magnesium oxide formed during the reaction is the product. Okay, this is the basic thing. Okay, that we, this is the basic things. Okay, okay, a word equation shows change of reactants to products through an arrow placed between them. This is the arrow placed between them. The reactants are written on the left hand side. Okay, reactants on the left hand side and plus between them, left hand side with the plus sign between them. Okay, this is the plus sign. Products are written in the right hand side with the plus sign between them. Here there is no another product, so it is not necessary to write down a plus. So this is the ultimate product. The arrow head points towards the product and show the direction of the reaction. Okay. Writing a chemical reaction. What is the process to write a chemical reaction? Is there any another short way to represent chemical equation? Yes, chemical equations can be made more concise and useful. That means concise means short. More shortly and useful if we use chemical formulae instead of words. A chemical equation represents a chemical reaction. If we recall formula of magnesium, oxygen and magnesium oxide, the above word equation can be written as Mg plus O2 equals to MgO. This is the shortest form of a chemical equation. Mg plus O2 arrow MgO, magnesium oxide. This is magnesium oxide, this is the product magnesium oxide. Count and compare the number of atoms of each element of the LHS and RHS of to the arrow. Is the number of the atoms of each element are same on both the sides? Okay. uh, Now we can calculate the atom. Mg is 1 atom, here oxygen is 2 atom, but here oxygen is 1 atom, Mg is 1 atom. Magnesium is the same, but oxygen is different, number of oxygen is different. Okay. Such this is, so this is an unbalanced equation. The mass is not the same of the both sides of the equation. Such a chemical equation is a skeletal chemical equation for a reaction. This is called the skeletal chemical equation for a reaction. Equation 1.2 is a skeletal chemical equation for the burning of magnesium in air. Equation 1.2 is a skeletal chemical equation for the burning of magnesium in air. This is the equation. Okay, this is the equation. Okay, please wait 1 minute. I am checking about the live streaming. It is streaming or not. Temperature. These are the main determining factor. Okay, as we observe the changes around. Okay. Okay. আচ্ছা, এখানে অনুপম আছিস তাই তো? হ্যাঁ অনুপম, ম্যাথস করাবো। ম্যাথসের ম্যাথসের ক্লাস করাবো। অনেক দিন করানো হয়নি, ম্যাথসের ক্লাসও হবে। ম্যাথসের ক্লাসও আসছে, শীঘ্রই আসবে। চ্যাপ্টার ওয়াইজেই করাবো বা প্র্যাকটিস করাবো, ঠিক আছে? আচ্ছা, দেন ওকে, ব্যালেন্সড কেমিক্যাল ইকুয়েশন। রিকল দ্য কল অফ কনজারভেশন অফ মাস দ্যাট ইউ স্টাডিড ইন ক্লাস 9. Okay, balance chemical equation. What is balance chemical equation? It is nothing but here we can balance the atomic number, or that means atoms of the elements, that is magnesium, oxygen. Okay, now mass can neither be created or destroyed in a chemical equation. This is called the law of conservation of mass. It is very important uh, about the if you are appearing the railway exams such as NTPC or Group D, then it is very very important law of conservation of mass. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. This is the law of conservation of mass. It is important on the perspective of railway exams. In other words, the number of ঠিক হ্যাঁ অনুপম ঠিক আছে okay Anupam, in other words, the number of atoms of each element remains same before and after a chemical reaction. Hence we need to balance a skeletal chemical equation. Is the chemical equation 1.2 balanced? Now we go to the 1.2 equation. Where is the 1.2 equation? 1.2 equation 1. No, cannot see about. Okay, let us learn about the balancing a chemical equation step by step. That is zinc and sulfuric acid, zinc sulfuric acid, zinc sulfate plus hydrogen, zinc plus sulfuric acid, and this is the skeletal chemical equation. Okay, Zn plus H2SO4 equals to ZnSO4 plus H2. Here Zn is the zinc and H2 is the hydrogen. This is sulfur and oxygen. Now we can see that here the in the left hand side the number of Zn atom is 1, hydrogen atom is 2, sulfur atom is 1, and oxygen atom the number of atom is 4. But in the product section the number of Zn is also 1, number of hydrogen is also 2, sulfur is also 1, and the hydrogen is also 4. So this is a balanced chemical equation. So this is a balanced chemical equation. Okay, this is a balanced chemical. Let us try to balance the following chemical equation. Fe plus H2O, Fe, this is iron plus H2O water equals to Fe3O4 plus H2. Okay, okay, Fe plus H2O4, this is an important equation. Fe plus H2 equals to Fe3O4 plus H2, this is hydrogen. Now the number of Fe atom is 1 and hydrogen atom is 2 and oxygen atom is 4, but in the product section Fe is 3, hydrogen is 2 and oxygen is 4. Now we have to balance the equation. At first step is to balance a chemical equation. First draw a box around each formula. Do not change anything inside the boxes while balancing the equation. Okay, list the number of atoms and different elements present in the unbalanced equation 1.5. Okay, and step 3, if it is often convenient to start balancing with the compound that contains the maximum number of atoms, it may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Okay, at first step 3, if it is often convenient to start balancing with the compound that contains the maximum number of atoms, it may be a reactant or a product. Okay, it may be reactant. Here the maximum is 2, here the maximum is 3. Using this criteria, select the element which has the maximum number of atoms. Here Fe is the Fe has Fe, the number of Fe is maximum 3. Okay, there are 4 oxygen atoms. Using these criteria, we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the RHS and only 1 in LHS. Okay, Fe3O4. Okay, Fe3O4. Okay, the element there are 4 oxygen atoms in the RHS. Sorry, this is the maximum. This is the maximum. To balance the oxygen atom, initial initial process is in H2O, and in the products there are 4 in Fe3O4. Initially in the oxygen will contain in water, and this is in Fe3O4. Okay. Now, to equalize the number of atoms, it must be remembered that we cannot alter the formula of the components or elements involved in the reaction. Okay. For example, to balance oxygen atoms, we can put coefficient 4 as 4H2O, not H2O4. Okay, or H2O whole 4. This is not possible. Okay, now the now the partly balanced equation is Fe plus 4H2O equals to Fe3O4 plus H2O. Okay, now we can start. Fe plus H2O equals to Fe3O4, Fe3O4 plus H2. Okay, here oxygen, here maximum oxygen 4, here 2. So if we write down 4, then the hydrogen is 8, but here hydrogen is 4, 2. So if we 4, then hydrogen 8, Fe, here Fe is 3, but here Fe is also. So this is the balanced equation. Okay, you can see the process also. Step 5, Fe and hydrogen atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of H atom, make the number of molecules of hydrogen as 4 of the RHS. I would say the process, but you can read from this. Initial hydrogen, okay, to balance it. Okay. Step 5. Examine the above equation and pick the third element which are not balanced. Okay. Initial to balance. Okay. This is the process. You can see it. And finally, 3Fe plus 4H2O equals to Fe3O4 plus 4H2O. So this is the 8 hydrogen atom. This is 8 hydrogen atom, 3 ferrous atom, 3 ferrous atom, and 4 oxygen atom, 4 oxygen atom. Okay. The numbers of atoms of the of elements on both sides are equal. The equation is not balanced. This mentioned of balancing chemical equation is called heat and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. This is the called heat and trial method. Heat and trial method of balancing the chemical equation. Okay, chemical equation. Okay, now step 7, writing symbols of physical states. Carefully examine the above balanced equation. Does the equation tell us anything about the physical state of each reactant and product? No information. This is important. No information has been given in the equation about their physical status, okay, or states. To make a chemical equation more informative, the physical states of reactants and products are mentioned along with their chemical formula. The gaseous, liquid, aqueous and solid states of reactants and products are represented by the notation G, L, aqueous and S. Okay, this is liquid, this is gaseous, liquid, aqueous and solid respectively. The word aqueous is written if the reactant or product is present as a solution in water. Okay, 3 FeS, S means here solid, this is solid, this is solid, and this is the gaseous. Okay, now the symbol G is used with H2O to indicate this is the reaction water in is used in the form of steam. Okay, so we all know that H2O is water is liquid, but here H2O is used in the form of gaseous. That means steam, in the form of steam. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Okay, sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated about or below the arrow in the equation. For example, okay, for example, CO plus H2 equals to CH3OH, and CO2 plus 6H2O equals to C6H12O6 plus 6O2. This is the equation of photosynthesis. This is the equation of photosynthesis. Okay, 6 CO2 plus H2O. This is carbon dioxide and water. The products will be glucose and oxygen. Okay, using the three steps, and this is carbon monoxide and hydrogen equals to CH3OH. Okay, methanol. This is methanol. Okay, 1 minute. Now the question is, why should a magnesium ribbon be cleaned before burning a air? Okay. Second, write the balanced equation of the following chemical equations: hydrogen chlorine, barium chloride, sodium water. Write a balanced chemical equation, and this is the solution of barium chloride, solution of hydrogen oxide. Okay, you can try it in your home. Okay. Okay, types of chemical reaction. What are the types? Combination reaction. This is the first type, combination reaction. Second is decomposition reaction. Combination reaction, decomposition reaction. Third is displacement reaction. Okay, combination, decomposition and displacement. Okay, and fourth is double displacement reaction. Fifth is oxidation and reduction. Okay, so what are the types of the reactions? What are the types of the reactions? Okay, I am writing here. First one is combination reaction. Combination first one is combination reaction. Second is decomposition reaction. Third is displacement. Reaction. Fourth is double displacement. Fifth is oxidation and reduction. Okay, now we can study about the details of the reaction. What is combination reaction? Combination reaction, for example, calcium oxide reacts vigorously with water to produce slaked lime, calcium hydroxide, releasing a large amount of heat. That is, CaO, quick lime with water made slaked lime or makes slaked lime. Okay, that these are the components in this reaction: calcium oxide and water. Calcium oxide, this is quick lime, and calcium hydroxide, that is slaked lime. It is important. The name of the reactants and products are the important. Well, this is quick lime and this is slaked lime. Calcium oxide and water combine to form a single product, which is calcium hydroxide. That is, it converts into a single product, so it is called the combination reaction. Two or is from two or. So what is the definition? Such a reaction in which a single product is formed, two or more reactants is known as the combination reaction. Okay, what is basically here said, that two or more reactants makes a single product. This is called the combination reaction. Okay. There are another examples, which is burning of coal. Carbon plus oxygen equals to carbon dioxide, hydrogen plus oxygen equals to water. Okay, these are the basic equations. Here, burning of natural gases, methane, CH4 plus O2 equals to carbon dioxide equals plus H2O. Okay, do you know that respiration is an exothermic process? Okay, activity 1.4, we also observe that a large amount of heat is evolved. This makes the reaction mixture warm. Reaction in which heat is released along with the formation of product is called the exothermic equation. What is exothermic chemical reaction? When the heat is released along with the formation of the products. These are the exothermic equation. This is not a composition reaction, but this is a exothermic reaction. Okay. We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into similar substances. For example, rice, potatoes and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cell of our body and provides energy. This special name of this reaction is respiration. What is respiration? This is the respiration. Glucose along with oxygen forms energy. This will study in the class, which you will study in chapter 6. Okay. Glucose plus oxygen equals to carbon dioxide plus water plus energy. Okay, C6H12O6, the chemical formula of glucose, and 6O2 plus 6CO2 plus 6H2O equals to energy plus energy. The decomposition of vegetable matter into compost is also an example of exothermic equation. The decomposition of vegetable, okay, it is an also exothermic equation. Now, decomposition reaction. What is decomposition reaction? Here, do not point the mouth of the boiling tube at the neighbors of yourself. Okay, this is the burner. This is the boiling tube. Ferrous sulfate crystals wafting gas gently towards nose. Okay. Activity 1.5. Take about 2 gram ferrous sulfate crystals in a dry boiling tube. This is the ferrous sulfate. Okay. Note the color of the ferrous sulfate crystals. Note here, heat the boiling tube over the flame of a burner or spirit lamp as shown in figure 1.4. Okay. Observe the color of the crystals after heating. Okay. Correct way of heating the boiling tube containing crystals of ferrous sulfate and the smelling of color. Have you noticed the green color of the ferrous sulfate crystals has changed? This is green in color in normal situation or in the home temperature. You can also smell the characteristics odor of burning sulfur. FeSO4, ferrous sulfate, along with heat, it converts into Fe2O3, ferric oxide plus sulfur dioxide plus sulfur trioxide. Okay, in this equation reaction, you can observe that a single reactants breaks down to give similar products. Here is a single reactants, but it breaks into three another products. So this is called the decomposition. Decomposition. At first said uh, we have said about the combination reaction, and uh, this is the decomposition reaction. Okay, this is FeSO4 is ferrous sulfate and Fe2O3 equals to ferric oxide. Okay, this is the decomposition reaction. Ferrous sulfate loss water when heated and the color of the crystals change. It then decomposes to ferric oxide, Fe2O3, sulfur dioxide and sulfur trioxide. Ferric oxide is a solid while SO2 and SO3 are gases. This is solid. Okay. Decomposition of calcium carbonate. Calcium carbonate decomposition reaction, it converts into calcium oxide, which is quicklime, and carbon dioxide. This is gram. Okay. Okay, now I will finish the class after few minutes, uh, after activity 1.6, after the completing the decomposition reaction. Okay, and the what is the another example of decomposition reaction is equals to lead nitrate PbNO3 whole 2 equals to 2 PbO plus 4 NO2 oxygen. Okay, lead oxide, and this is lead nitrate. It converts into three another products. This is also a decomposition, some decomposition reaction as given. This is lead nitrate PbNO3 whole 2, lead nitrate, lead oxide PbO. Okay. Okay, this is the electrolysis of water. It converts into hydrogen and oxygen, converts hydrogen. Activity 1, take a plastic mug, drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers as shown in 1.6. Electrolysis of water. Connect these electrodes to a 6-volt battery. Fill the mug with the water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. Okay, switch on the current and leave the apertures undisturbed for some time. You will observe the formation of bubbles at both of the electrodes. These bubbles displaced water in the test tubes. Is the volume of the gas collected the same in both the test tubes? Once the test tubes are filled with the respective gases, remove them carefully. Test these gases one by bringing a burning candle close to the mouth of the test tubes. Caution: to step must be performed carefully by the teacher. What happens in each case? Which gas is present in each test tube? Okay. And the sunlight 1.8, take about 2 gram silver chloride in a china dish. What is its color? Place them china dish in sunlight for some time. Observe the color of the silver chloride after some time. China dish, and this is silver chloride. You can see that silver chloride turns gray in sunlight. This is important. This is due to the decomposition reaction of silver chloride into silver and chlorine. Silver chloride can decompose to silver chloride turns gray in sunlight to form silver metal. Silver bromide also behaves in the same. Silver AgBr equals to Ag plus Br. The above reaction are used in black and white photography. This is important. AgBr, silver bromide, black and white photography. There it is used in the black and white photography. What form of energy is causing this decomposition reaction? We have seen that the decomposition reaction requires energy either in the form of heat, this is the sunlight, light or electricity for breaking down the reactants. Reactions in which energy is absorbed are known as the endothermic reaction. Which reactions in which energy is absorbed is called the endothermic reactions. Okay, now the class is over. So thank you everyone. See you in the next video. Okay.